Good evening, everyone. Welcome to the Brian Crombie Radio Hour on Saga 960. So I thought that, given where we are going into, according to newspapers just this past weekend, the sixth wave of this COVID-19 pandemic, that it would be helpful to check in with Dr. Craig Laferriere, who is an expert in vaccine development. He actually is the head of vaccine development at Novature Ventures. He's been in vaccines for quite a long period of time with GlaxoSmithKline. He's taught at the University of Ottawa, University of Toronto, Mississauga. He's been a senior scientist with GSK and with Pfizer, a regional medical research specialist, a medical advisor, and now a consultant in vaccine manufacturing and licensing. Craig, I understand that you've done a couple of presentations recently to groups about sort of the history of vaccines and sort of explain to people what vaccines are all about, where they come from, what their benefits are, and obviously try to educate people on how powerful these vaccines can be for COVID-19. Is that the case?
That is, yes. In fact, the whole presentation is available on YouTube for people who want it. I can give you the link. But we can go through a briefer version here on your show.
Please, go ahead. Tell us a little bit about the history of vaccines by Dr. Craig Laferriere.
All right. Well, I'll just share my screen with you. So the approach that I decided to take with this was to introduce people to the different types of vaccines that are being used against COVID by showing the historical development of each type of vaccine. And so that started with all of this comes from a paper that we published in early 2021 about the early phase 3 results that were coming out of the different vaccines. And so in this, there are basically 4 different technologies that have been used to make COVID-19 vaccines. So there's the inactivated virus type. There's the protein subunit type of vaccines. There are the viral vector type of vaccines. And then there's the messenger RNA type vaccines.
And the inactivated virus is the type of vaccines that historically most people would be familiar with. Is that the case?
I beg your pardon?
The inactivated virus vaccines is sort of the historical type of vaccines that most people would be familiar with.
That's correct. Yes, the influenza vaccines are made from inactivated virus. The Salk polio vaccine is an inactivated virus. Most viral vaccines are inactivated. You do have the attenuated virus type vaccines, measles, mumps, rubella, where it is a live virus, but it's been weakened. And there is, for COVID-19, that type of technology is not being used.
And the RNA is sort of the vaccines that have just for the first time been used now. I understand that they were initially developed, a lot of them for cancer, potentially, but were quickly routed through for COVID-19. Is that the case?
Yeah, this technology, the messenger RNA technology, has been developing really for, although people seem to think it's quite recent, in fact, the technology has been developing for 30 years approximately. And the whole trick behind the messenger RNA vaccine is that if you just injected messenger RNA into someone, there are enzymes in your blood that would quickly degrade the messenger RNA into fragments. And the way to stop that, this was discovered actually in 1978, was to simply encapsulate the messenger RNA in a little droplet of fat. And that stops the enzymes from degrading the messenger RNA. And then as it turns out, your cells have a tendency to eat little droplets of fat for a variety of metabolic reasons. And so then that gets the fat inside the cell, and then that piece of messenger RNA gets released. And then your body thinks, or the cell thinks, oh, this is just a piece of messenger RNA that's part of my whole metabolism. It has a code in it for a protein. I'm going to produce the protein that messenger RNA codes for, and it produces the protein. So the idea for for a lot of messenger RNA technology was a therapeutic to get proteins into cells that for some reason the person has a genetic defect, or the gene is turned off for some reason. So you want to get that protein inside the cell. So the way to do it is to get the messenger RNA inside the cell and have the cell produce it right inside. And there has been some, good indications that this might actually, be a successful approach for diseases, such as the respiratory diseases where I'm blanking on the name of the disease, where they have a problem with production of mucus. The mucus that's produced inside the lungs is too thick. And the name of that disease is, I'll have to edit this part out. Anyway, it'll come to me, but I can't remember it right now.
And the protein versions, Medicago, that's a Quebec-based company, I understand, that has an operation in Brampton or Mississauga as well, and that was grown on tobacco leaves, I understand.
Yes, very interesting technology that they've got that was licensed recently in Canada. They, at the time last year when we put out this paper, the results hadn't come in yet, but the results were announced. I think the efficacy was about 75% against symptomatic COVID. And the way it works is that you grow tobacco plants, and then you infect the tobacco leaves with a bacteria, and the bacteria introduces the genes inside the tobacco leaf cells, and then it takes over those cells and they start producing the protein that you want that's inside this bacterial vector. And so what they did is they, of course, inserted the gene for the spike protein. And so then the tobacco leaves begin producing the spike protein. And then the real trick to this technology is that they add something that causes the proteins to assemble into what is known as a viral-like particle. And these viral-like particles are sort of extruded outside of the cells, and it makes them very easy to purify. And that's really the trick of their technology. They can produce huge quantities of this vaccine at very low cost. It's just like having a greenhouse, and you just grow plants. It does take a bit of time, of course, to grow the plants up to the right size, but once they are the right size, then you can produce large amounts of these recombinant protein vaccine.
Fascinating. And the numbers that you've got here on efficacy are quite interesting, ranging from below 50% efficacy for the Bharat Biotech to 50% for the Sinovac, up to 95% for the Pfizer and 94% for the Moderna. Why such a wide range in efficacy?
Yeah, that's a really good question. And I think the reason probably is that the way your immune system responds to these different technologies. To me, one of the ones that's surprising is the Novavax, which is at 89%, almost 90%. The way viruses work, of course, is that they infect inside your cells. And so you need two branches of your immune system to protect you against a virus. You need the antibodies that stop the virus from even entering the cell. But once the virus is inside the cell, then you need to be able to get at it. Of course, an antibody can't enter the cell. So you have a certain branch of the immune system called the cellular immune system. And that branch of the immune system will actually destroy the cells that are infected. It's able to recognize them. It recognizes that there's a foreign protein inside that cell. And so it will cut off. First of all, the cell will shut down its metabolism, stop producing everything, and then eventually the cell will be killed. Now, the way to stimulate both branches of that immune system has been to get something inside the cell. And the inactivated virus and the recombinant protein types, that antigen is not inside the cells. It's on the outside of your cells. So you get the antibody response, but you don't necessarily get the cellular type responses. when you get the antigen inside the cell, like you get with the messenger RNA type vaccine, then you stimulate both branches of the immune system, and that probably accounts for the higher efficacy. Now, you might think the viral vector types also, they should work because they're also producing the antigen inside the cell, but their range also is lower, from 65% up to 90% from the Gamaleya Sputnik vaccine. But there's actually some papers on the internet that suggest that the data from Sputnik vaccine was faked. It's probably not that high. And so why didn't those vaccines have high efficacy also? Because the antigen was produced inside the cell. And the reason for that may be that the whole viral vector approach is that it uses an adenovirus, and people may have been previously exposed to the adenovirus. And so the virus doesn't even have a chance to get inside the cell and start producing the spike protein. It's destroyed even before it, even as it gets inside the body. So that may explain why the viral vector types don't have the same kind of high efficacy as the messenger RNA vaccines.
That's interesting. What's the virus called? The venovirus?
Adenovirus.
And where would one have gotten that from?
It's a common cold. It circulates around in North America. Apparently 10% of people have been exposed to adenovirus. It's a bit higher in Europe, around 30%. And in East Asia, it's as high as 50% of people have been exposed to adenoviruses.
And this is a common cold virus. And if you've gotten it, what your hypothesis is that you've already created antibodies against it, and such that when a vaccine with it is inserted into your body kills off the vaccine because it thinks it's the virus.
Yeah, it's seen that virus before, and it just kills it off before it has a chance to do anything.
That's fascinating. We're chatting with Dr. Craig Laferriere tonight. He is a vaccine expert. We're getting an overview of vaccines. We're going to take a break for some messages and come back more with Craig in just a minute. Stay with us, everybody. Welcome back, everyone, to the Brian Crombie Radio Hour on Saga 960. Dr. Craig Laferriere has joined us tonight. He's an expert in vaccines. He's worked with GSK, with Pfizer, with several other companies in vaccine development and vaccine research. He's taught at the University of Toronto at Mississauga. And he's actually been a candidate for the Green Party in the past. So he's an environmentalist. He's a very spiritual gentleman. And he's one of the smartest guys I've ever had the privilege of meeting, particularly from a scientific standpoint. Dr. Laferriere, you were telling us a little bit about the different types of vaccines. And why would you want to explain the different types of vaccines to people when you do these presentations? Is it helpful for people to understand the differences? And do people then want to get the AstraZeneca or get the Moderna? What's the benefit of explaining these different types of vaccines?
Well, I think one thing that I've noticed in talking to people is that the new technologies, the messenger RNA technology, is not very well understood. And I've heard some people that are afraid of it. Frankly, they think it's going to modify their DNA, and they don't want that. Or they've heard that, and the more extreme ends, they've heard that they're going to get a chip inserted into them or something from the vaccine. So I think trying to bring people up to speed on what this technology is about and how it works just helps in general for people to understand vaccine technology and to make it more acceptable.
I've been shocked at how many people are against vaccines. And, you'll know the statistics, I presume, but vaccines have really benefit our society, our population, our world dramatically over the course of the last 100 years or so, have they not? When you think about, polio and other, diseases that just have been eradicated or almost eradicated because of vaccines. Give us a sense, if you could, of the history of the success of vaccines and what the impact has been on society. And then maybe comment about why you think that this vaccine hesitancy, if not outright, deniability of their effectiveness, has grown in the last couple of years. That's
a very good question, and I did have some numbers prepared. I'll have to try to see if I can pull them out of my head. But there's been some estimates on how many lives have been saved from vaccine over the last 10 years, let's say. And I've seen numbers as low as 5 million and numbers as high as 50 million. So an order of magnitude difference. And I tend to go on the higher side about how many lives vaccines have saved just in the last 10 years. So there really is a, you know, huge benefit to vaccination that I don't think we, you know, people who, well, this is often said that people nowadays don't appreciate the lack of disease that we have. In, you know, just 100 years ago, if a child made it to 5 years of age, that was a big thing, that you had very high mortality rates and children under 5, and this was all due to infectious diseases. Nowadays, when it's just so rare, and in fact, there was, when some of these vaccines started coming out, people were concerned that physicians would no longer be able to recognize the symptoms of certain types of diseases. You know, for example, Haemophilus influenza type B, the vaccine for that came out in the early 90s. And it used to be something that a physician would recognize right away and would know how to treat it. But then when physicians were seeing it less and less, it didn't become an immediate signal to them. They didn't recognize the symptoms right off the bat and knew how to recognize it. So it's the fact that we live in a world that's so free of really serious infectious diseases is something that a lot of people don't appreciate. They just have to, you know, take a look at I always, you know, give the example of reading one of the, you know, 19th century novels, and, you know, the heroine or the hero, you know, gets sick and dies. And that's, you know, that's part of the tragedy of the story of those novels in those days. And that was the reality. A lot of people did die of infectious diseases in those days, and we just don't have that anymore.
What was the first vaccine developed?
So the first vaccine developed was the smallpox vaccine. And it was actually, there's a little bit of dispute about whether it was the ancient Chinese or the ancient Indians that invented it. And what the technology was somebody who had developed smallpox, they would get scabs on their skin from all the pustules that form from smallpox. And then you could take that and use that to either put up the nose or put under the skin of a person who had never been exposed. And then that would give them a case of smallpox, but it was usually milder than if you caught the smallpox in the wild. And that technology was brought to England in the late 1700s, and by Lady Mary Montagu, I believe is the name, and was introduced into England and was promoted, and you know, it turned out that the death rate from this vaccine was 3% compared to the death rate of 30% if you got caught wild smallpox. So that was really the first vaccine that was used anywhere. But about 100 years later, Jenner came along and made a very important observation, and he noticed that cows also got a form of smallpox called cowpox, and that milkmaids who were exposed to cowpox never seemed to get smallpox. And so he had the idea, why don't I intentionally infect somebody with cowpox? And indeed, and then they did these tests actually even on prisoners, and showed that by infecting them with cowpox, and it was a very mild disease, you got maybe one pustule and then you recovered from it. So really a sort of a 0% death rate from that. But then these people were protected from the deadly form of smallpox. And Jenner didn't exactly know what he was doing. They had no idea about viruses. They didn't know what caused smallpox, but he figured out that this was a way of inoculating people, of causing immunization. And it took off and spread around the world, and was a great success. So the Edward Jenner invented that and was recognized by the Crown in England for making that discovery. And it was the very first really human invented vaccine.
Fascinating. And then, just in the last 100 years, vaccine development has taken off, has it not?
Oh yeah. I mean, after that, along came Louis Pasteur, and he took the ideas of Edward Jenner. And then at the same time, this was in the late 1800s, microscopes were being used, and they were beginning to see little things under the microscope. And the idea was coming out, was being presented, that these little things you could see under the microscope was what was caused a disease. And this was disputed. A lot of people didn't believe it, but Pasteur certainly did. And he went and created a bunch of different vaccines. For example, the rabies vaccine, anthrax vaccine, based on the idea that you inactivate these little animalcules, injected them into people, and that created immunity against these infectious diseases.
And so these were primarily either inactive viruses or small versions of active viruses that were the vaccines at the time?
That's right.
And that's sort of what most people historically think of, I think, when they think about vaccines, is this, you're actually getting a small amount of the virus or an inactive version of the virus injected into you. And, when I was growing up, we all had to line up at school. We had these little yellow cards, and we had to get a whole bunch of vaccines. And it was sort of standard. It was accepted. Everyone had to do it.
Yeah. One of the stories that I tell about when people ask me, why did you get into vaccines? And I tell the story when I was just after I graduated, I became a volunteer teacher in West Africa, in Ghana. And there was a hospital associated with the secondary school where I was teaching. And I used to go over there and visit the students, not the students, the patients that were in the hospital. And it was an orthopedic surgery hospital. And there was a surgeon who would come down from Spain and operate on the children who were crippled. And then they would recover and go home. And one day when I was visiting the children, there was a nurse there with me. And I asked him, why are there so many crippled children in this country? And he said to me, oh, it's from polio. And I was really, quite taken aback, because I had the same memory as you of being a kid in elementary school and lining up to get our polio shots. And so how was it that this was in the 1980s, how was it that this country in the 1980s did not have access to polio vaccines that would have prevented these kids from being crippled for the rest of their lives? I mean, they did have this surgery that helped straighten out their bones, but still they were more or less crippled. And that started me on my career to go into vaccine research and development.
Because of what you saw in Ghana. That's amazing.
Yeah.
And you spent your whole career in vaccine development. Is that correct?
Yes, I have.
So why do people question it so much today?
I have a theory about this, it's very diversified. I think there's a lot of different reasons. The number one reason probably is people either know someone or have themselves experience an adverse event from a vaccine, from having received a vaccine. And the reality is that vaccines do trigger an immune response. That is what vaccines do. And so you're going to have cold or flu-like symptoms because it's turning on your immune system. Your immune system thinks you're sick. And so it's going to give you the symptoms that you get when you're sick. The advantage of it is that it's not really making you sick. It's just making you think you're sick. And so you recover after 2 or 3 days. The fever, the headache goes away. But now you've created immunity and you're protected against the real disease. But nevertheless, there are turning on your immune system like that can, in some instances cause adverse events, especially the most common one, of course, is allergic reactions.
Right.
Allergic reactions tend to be the most common negative side effect from vaccines. And the fortunate thing about that is we know how to deal with allergic reactions. And so people who tend to have allergies, carry around an EpiPen with them And so if they do have an allergic reaction, it can be anticipated and it can be managed.
We're chatting tonight with Dr. Craig Laferriere about vaccines. We're going to take a break for some messages and come back more in just a minute with Dr. Laferriere about vaccines. Stay with us, everybody. Welcome back, everyone, to the Brian Crombie Radio Hour on Saga 960. The topic tonight is vaccines, and we've got Dr. Craig Laferriere, who has spent his career in vaccines. Let me give you a little sense of this gentleman, if you could. He's got a bachelor's of honors in science at Carleton University in organic chemistry. He's got a PhD in synthetic organic chemistry from the University of Ottawa, and his thesis was on the synthesis of salicylic acid antigen. Sounds like a fascinating thesis. Would love to know a little bit more about that. He became a teacher with the YMCA and a volunteer in Ghana, West Africa, and that's where he first, as he explained to us, saw people with polio and got motivated to get involved in vaccines. He was a research fellow with Health Canada and worked on prepared monoclonal antibodies to heat shock proteins, and that sounds interesting. And antibodies have become one of those topics of late, and so I'd love to chat with you about that. He then became a scientist with the National Research Council and worked on different vaccines. He was a member of the European Bacterial Conjugate Vaccine Network for 5 years. He was a senior scientist with GlaxoSmithKline, where he developed and implemented Canadian vaccines clinical research strategies. He was a consultant with PATH and advised vaccine manufacturers on the preparation of conjugate vaccines. He was a lecturer at the University of Toronto on organic chemistry, and he's been a regional medical research specialist and medical advisor for Pfizer Canada, responsible for therapeutic strategy, clinical research, program management, and leadership, and also worked on vaccines, and then was a consultant on vaccine manufacturing and licensing at Canvax for 26 years, where you did consulting, and you're currently the head of vaccine development at Novature Ventures, Inc. So you've got a wealth of experience in vaccines, just no question about it. Tell us a little bit about the Sputnik vaccine that you said may have had faked results.
Yeah, this is something that's very interesting. We, in part of our paper that we published early in 2021, we were trying to show that there was a relationship between the antibody response as measured by a neutralization assay. So that's the ability of the blood from a person who's been vaccinated, the ability of that to stop the virus from causing an infection in some kind of cell that you may have in a petri dish or in a bottom of a test tube. And that's the common assay that's used around the world. And you want to do those kinds of tests to see what kind of immune response people are having against your vaccine. And what you want to show is that there is a relationship between that antibody response and clinical protection. And the reason why you want to do that is because you don't want to have to run clinical trials every time you make some kind of change to your vaccine. You don't want to have to run an efficacy trial where you have a placebo control and some people are getting sick, whereas you're 95% sure that this vaccine works. You don't want to have a placebo control. So what you want to be able to show is just by a blood test that this person is protected against the disease. So the way to do that normally is to show a correlation. So you draw a graph and you show what kind of efficacy did they get against disease on one part of the graph. And on the other part of the graph is what kind of antibody response did they get? How strong was the antibody response? And you can draw then a line. The lower the antibody response, the lower the efficacy is. We saw earlier the different vaccines had different efficacies going down from 50% up to 95%. So we did a graph of that, those efficacies in the clinic compared to the antibody responses. And you get a statistically significant correlation. But one of the things we noticed was that the Sputnik vaccine was out of line. It had a low antibody response, but they claimed it had a very high efficacy. And it was, we really debated for a long time whether we would point this out in our paper that there was something wrong with the Sputnik vaccine. It wasn't fitting in with the rest of the data. Anyway, as it turned out, one more point came along, and which was another inactivated vaccine. It had a lower antibody response, but it had a little bit higher efficacy, and that threw away. Suddenly, the Sputnik vaccine was no longer significantly outside the norm. So we decided to, okay, we're not going to make any comment about it. We'll just leave it as it is, and we just left it in the graph. However, a few months later, there was a publication that came out about the Sputnik vaccine, and people had noticed that the other information in the clinical trial didn't make any sense, that some of the numbers that were being presented did not add up. And so it really came the question, well, in fact, in this publication, they said these data are faked. The data from the Sputnik vaccine are faked. And not long after that, Brazil, who had signed a contract with Russia to purchase the Sputnik vaccine, backed out of the whole thing. So to me, it's really curious that that whole affair, is what's going on in Russia. Do they have a vaccine that works, or was the whole thing faked? It's hard to believe that a vaccine institute would do that, but on the other hand, we're seeing that life in Russia it may not, freedom of speech and ability to say something is not necessarily the case anymore.
Now, if your numbers are correct and your conclusion is correct, one would think that there'd be, even if people had taken the vaccine, a huge number of far larger amount of mortality because of COVID-19 in Russia, if the vaccine wasn't actually efficacious. Do we have any sense that that's the case?
Certainly you've seen that I think also the numbers coming out of Russia, the number of cases of COVID and the number of fatalities don't add up. They're claiming far lower fatality rates, far lower infection rates than other places. And I'm trying to remember what was the evidence when I think when you looked at overall mortality, it didn't add up with what they were saying about mortality due to COVID. So they had seen an increase in mortality, but weren't attributing it to COVID.
Let me ask you a couple of other questions that come up, if I could. My first vaccine was the AstraZeneca vaccine, because that was what was available at the time for people in my age category, earlier than other vaccines were available. And there were a bunch of side effects about the AstraZeneca vaccine that ended up discouraging its use. Tell me, what were the side effects and how serious were they?
So the side effects that were observed with this viral vector type of vaccine, and maybe I'll just say a few words about the viral vector. And I mentioned this earlier, it's an adenovirus. It's based on an adenovirus, but some of the genes are removed from the adenovirus, so it can no longer replicate. So it's called a non-replicating viral vector. And those genes that have been removed, some of those genes have been replaced with the spike protein from COVID. So early data with that particular type of vaccine showed that there was an increase in strokes, and these strokes were associated with low platelet counts. So that's called, the technical term for it is thrombocytopenia. And this is a type of stroke that had never been seen before. And it was certainly clearly, there was a timeline also. It was usually within a month of having received the viral vector vaccine. It also seemed to be more common in women than in men, and also women between the ages of 25 and 50. And there was some question of, well, is it associated also with, use of contraceptives? Because that's also the age group where the contraceptives are used, and contraceptive use is also associated with strokes in that age group with women. But they couldn't actually find any kind of correlation with use of any contraceptive. So it seemed to be something completely new. The number of cases that were occurring was somewhere around 10 cases in a million. And, or 1 in 100,000, and maybe even, higher, 1 in 50,000, let's say. So it's still an extremely rare event, fortunately. And when you compare that to strokes caused by people who are actually having the wild disease, who are having COVID, the rate of people having stroke from that is substantially higher. And I tried to look up the numbers for that to see how much higher is it. And it's a little bit difficult to detect because you have different ways of defining who has COVID. Is it hospitalized COVID or is it non-hospitalized COVID? But either way, the numbers that I was able to come up with was that having stroke from COVID was around 100 times higher than getting stroke from the vaccine. So on a risk-benefit basis, the adenovirus vaccine is still, very much has a positive risk-benefit ratio. It's still much less risky having the vaccine than it is getting the virus. On the other hand, though, people tend to be very intolerant of any side effects from vaccine. And so because the messenger RNA vaccines did not seem to have this side effect, there's been a tendency then in Canada to move towards the messenger RNA type vaccines, in addition to the slightly higher efficacy.
Some people have liked the idea of mixing and matching different types of vaccines and think that there's some benefit to that. And then other people know, once I get one vaccine, I want to always get that vaccine. What's your sense of which is better?
Yeah, this one's a tricky question. And the problem with mixing vaccines is that technically it's not licensed. When a pharmaceutical company runs a study, they run the study in a certain way. And when they get a license to sell that vaccine, that vaccine has to be used according to the way in which this clinical study was done. And when you start making changes to that, there haven't been safety studies done, there haven't been efficacy studies done, so it's kind of a shot in the dark. Certainly the pharmaceutical companies cannot promote that kind of thing because it's not licensed, and so that would be what they call off-label promotion. And pharmaceutical companies, especially in the United States, get hefty fines for doing any kind of off-label promotion. On the other hand, public health systems don't seem to have that same kind of liability, and they seem to be able to, do experiments on the public to see what might work. My personal opinion is that really, if public health is going to engage in this kind of experiments on the public, they need to do it in an ethical fashion. They need to have informed consent. They need to let people know that what we're doing to you is an experiment, and that this vaccine hasn't been licensed in this particular way, and get people's permission. And so that's my opinion. Of course, I come from the pharmaceutical side of things, and I like to see things done properly. Whereas, as I say, there's two sides to the story. There's also a very pragmatic side. You may decide that the risk of mixing vaccines is very low. The benefits are potentially greater. And so I think that's how they justify what they do.
We're chatting tonight about vaccines with Dr. Craig Laferriere. We're going to take a final break for a message and come back with some concluding comments about, how long we're going to continue taking these boosters, according to the doctor. Just stay with us, everybody, for a 2-minute break. Welcome back to the Brian Crombie Radio Hour on Saga 960. We're having a really interesting conversation with Dr. Craig Laferriere about vaccines. Craig, I've been careful for 2 years. I've been wearing a mask. I've been physically distancing from people. I've been really careful. And then, 2 weeks ago, Doug Ford lifted the mask mandate. And the very next day, I got COVID. After 2 years of being careful, taking the vaccines, et cetera. And it's hit me hard. I'm still recovering. I thankfully didn't have shortness of breath, didn't have to go to the hospital. But it's been a pretty tough cold, pretty tough sickness. Tell me, do you think that And it seems that according to the press, at least, that we're into this sixth wave. Do you think we've lifted our public health measures too soon?
That is a tough question to answer. My wife and I debate back and forth about this. I think for people who are immunocompromised, people who are elderly and who are at higher risk, it is a dangerous time for them. But I think for the general public, because we've all been vaccinated, so that when we're exposed to the virus, we have a very high chance of having milder symptoms and not ending up hospitalized, not ending up severely sick. I think the time, I come down on the side of it is time to open up. And the reason is that you need to supplement your immunity that you've gotten from the vaccine with natural immunity due to exposure to the actual virus. And that's the only way that we're going to learn to live with this thing, is that we learn to be exposed to the wild type of virus. Now, you probably, I've noticed for myself over the last 2 years, I don't get winter colds. I haven't had a winter cold in the last 2 years. And whereas in a typical year, I would at least have one, if not two, really nasty colds sometime during the winter. My nose would get blocked up. I'd have a sore throat. I would be miserable for about 2 weeks. I would take Cold FX or vitamin C or something to try and get rid of it. And I haven't had to suffer that for the last 2 years because we've been isolating ourselves. So I think we forget that these sort of nasty colds were common before, in the before times, as they say. So, I think if to go back to being social beings, and we are social beings, that we have to put up with these minor infections that we get. And I think, because of the fact that we've all had our third dose recently, now is the time to do it when we still have a good high level of protection. And now is the time to start getting exposed to real bugs again and building back up our natural immunity to all those bugs that are out there.
Really? So it's interesting. What you're saying is getting it was actually helpful, because now I'm going to have some super immunity for a while.
Hopefully, yes.
Okay, fascinating. I hope you're right. Do you think we're going to be all taking a fourth shot? Are we going to be taking boosters for the rest of our lives?
Yeah, it looks like this thing has insinuated itself into the human population. It has the ability to mutate, so it's here forever. I would say it's going to become like the flu virus. We'll probably have to have a shot every year or every second year, depending on the new strains that are circulating. That's the way I see it. It's going to be part of your annual shots. I think maybe, with the development of the messenger RNA vaccines, I think, and if influenza vaccine manufacturing switches over to those types, you can match, because the timeline to develop the messenger RNA vaccines is so much shorter than the traditional type of influenza vaccines, you can probably match the annual vaccine you're getting better to what's circulating. And so I would hope that that instead of having to get a shot every year, it could be moved to every second year or something like that. But it all depends on what data ends up happening down the road. We'll just have to keep things monitoring. But because with these messenger RNA vaccines, you can be flexible. If the virus hasn't mutated a lot, you can keep the same virus and hope your immunity lasts for 2 years. If a new strain appears, then after 2 years, it's time for getting a shot of the new strain.
Some people have said that this is the 100-year pandemic, and we had the Spanish flu in 1918 to 1920 or thereabouts, and this was the 100-year anniversary of that, so we were due. Other people have said no. We had SARS in 15 years ago, and we're going to get another one. What's your sense? Are we going to have to wait another 100 years for another pandemic, or should we be more concerned and expect something more soon?
That is really hard to predict. It's the appearance of a a virus that jumps from one species to another. And I think it's fairly well accepted now that this virus came from bats. It can just happen randomly. And it's really hard to predict when a next pandemic will appear. I think with so much international travel, I think that if some virus does jump into the humans and it starts spreading quickly, I think the fact that we have so much international travel, I think that assists in the creation of pandemics. But it's very hard to predict. I think we just need to be continually vigilant and keep our eyes open. And I think there was a lot of political issues, of course, at the start. If you remember of the whole COVID-19, people were denying. If you look back at the statements that various public figures were saying, oh yeah, we're going to be through this in 2 weeks or something like that. I think there was a lot of naivety about what a pandemic actually means for the world, and so this has probably prepared us a lot to be on guard. And so if we keep our guard up, I think we can react quickly to any new viruses that appear and keep them controlled. But if we let our guard down and start spending our money on weapons instead of on vaccines, then these things have a chance to make a break for it and come into the human population.
Dr. Craig Laferriere, I appreciate that people as smart as you are focused on our public health and on vaccines. Thank you for your efforts, and really appreciate you joining us today to tell us a little bit about the history of vaccines and the current vaccines and the fact that we're probably going to be taking a booster every year or every second year for the rest of our lives. Thanks so much for joining us.
Well, thank you very much, Brian. It's been a real pleasure speaking with you.
That's our show for tonight. I'm on every Monday through Friday at 6 o'clock on 960 AM. You can stream me online at www.saga960am.ca. All my podcasts and videocasts are available after the fact on briancrombie.com. You can get my videos on Facebook, Instagram, LinkedIn, and YouTube, and my podcasts on Apple, Audible, and Speakeasy Podcasts, and SoundCloud too. Thanks for joining us. Good night, everybody.